All right. Yeah. So Chapter 4, Section 1 is graphing quadratics, which all of you have seen before. The main thing that I want to start with is what is the difference between a linear function, which is what we've been spending a lot of time talking about, and a quadratic function. So for a linear function, right, who knows what standard form for a linear equation? It's ax plus by equals c, right? Everybody okay with that? So what's the general form, though? What's the form that we use the most of when we graph a linear equation? Y equals mx plus b. All right, so everybody good with that, yeah? What's the shape of a linear equation? A line. Okay, and what are the key values when you're graphing in slope-intercept form? M is what? And what's b? The y-intercept. So that's really all we pay attention to, right? If you give me the slope and the y-intercept, I can graph any line there is. Now, real quick, this is considered a first-degree function. So what I mean by that is, what's the biggest power on x here? If you look at the standard form, what's the biggest power on x? 1, right? What's the biggest power on x here? 1. So that's what creates the line, right? So remember in Chapter 2, there's that question that a lot of you had a hard time with. Is the following equation linear, yes or no? All you do is look at the power. Okay, if the biggest power on x is 1, then it is, in fact, a linear equation. All right, so now we're going to step it up to second-degree functions, which are called quadratic. So does anybody remember from last year what the standard form of a quadratic equation is? We're moving up to second-degree functions, which are called quadratic. So what do you think the biggest power on x is going to be in a second degree? There we go. So here's your standard form. Y equals ax squared plus bx plus c. Okay? So if you notice, it's a linear equation with a little bit extra, right? With an ax squared. So now it has a second degree piece on it, which means that the biggest power is now 2. Everybody okay with that? Yes or no? Okay, anybody remember what's the shape of an x squared function going to be? Okay, it's a U. Anybody remember what its name is? Yep, it's a parabola. Okay? So it's not a parabola, it's a parabola. I do want to go over this real quick. A, right? So if A is less than 0, the graph points which way? Down, right? So who remembers from last year, if the graph points down, did we create a minimum or a maximum? A maximum, right? It's kind of backwards from what you think. If the graph points down, remember, how far does it point, or how long does it point down for? Forever. So it can't have a minimum because it'll never hit bottom, right? But you are creating a maximum point where you can't go past where the vertex is. So if A is greater than 0, which way does the graph point? Up. So if it points up, do we create a minimum or a maximum? A minimum. Everybody okay with that? Okay. So, key values. So vertex. Anybody know anything about a vertex? Okay, it's a point, so that's one thing. Okay, so it's where it changes from decreasing to increasing or from increasing to decreasing, right? Anybody in here like big roller coaster fans? Okay, so you know like in the Magnum when you're in the front car and there's that point where you're hanging and you stop moving, right? You're not going forward yet because not enough cars have cleared the top, but you're hanging like down a 300-foot drop-off, right? That point is the vertex, okay? It's where you change from going up the hill to going down the hill. Okay, that change, or it's called a point of inflection. All right, so do you guys remember from English, what's inflection? Yeah, when you raise and lower your voice, right? So it's when something goes from increasing to decreasing, goes from up to going down. That's a point of inflection. So we have those with mathematics as well when we graph, okay? When your function is going up and then it starts going down, it passed through a point of inflection, which is the point right where it changes from one to the other. And that's what the vertex stands for. So does anybody remember how to find a vertex? There's a little formula for it. Anybody remember how to find the x-coordinate of a vertex? Negative b over 2a, right? No, that's the quadratic formula, which we'll get into. Negative b plus or minus the square root of b squared minus 4acl over 2a. Most of you learned that to the Notre Dame fight song, but I am a diehard Michigan fan and hate pretty much everything about Notre Dame, so I don't teach it to you that way. Mainly because I don't know the Notre Dame fight song. And I'm not going to learn it just so I can have you guys clap along. We'll just learn it, okay? Hey, to each their own, you know. If it works, it works. All right, so everybody okay with the x-coordinate? So is the x an independent variable or a dependent variable? Independent, right? What does that mean? Well, like when we graph, right, do we randomly pick y's and find x? Or do we randomly pick x's and find y's? We pick x's, right? So x is independent because it can be anything we say it is, right? Y is dependent because it depends on the x we pick. Everybody all right with that? So if I give you an x, how do you find the y that goes with it? What do you do with the x value? Plug it into the equation, right? So that's what this says. Find f of negative b over 2a, which means take the negative b over 2a and plug it back into the equation. Okay? That's just the fancy notation for it. Once we actually get into graphing them, you'll be like, oh, okay. All right. Min-max. When do we have a minimum? When the graph points which way? Minimums mean the graph points up. Maximum means the graph points down. And axis of symmetry. So what is the axis of symmetry? What does it mean to be symmetrical? Okay, the same, like how? Yeah, it's like if you cut an object in half, right? Like if you think of like a baseball, right? If you cut a baseball in half, you'll be exactly the same on the left side as the right side. Right? They'll be mirrored reflections of each other. Okay, that's what it means to be symmetrical. So like the block M, right? The block M is symmetrical. So if you cut it right down the middle and folded it over, you would get the exact same image. Everybody right? Okay. So for us, parabolas, which way do our parabolas go? Up and down or left and right? Up and down. So if I've got a graph like this and it's going to be symmetrical, where is the line of symmetry going to pass through? Right through the middle, right? Well, what point is right at the middle of a parabola? The vertex. So the axis of symmetry is going to be x equal to negative b over 2a because it's going to be a vertical line, so it's going to be just an x equal, and it has to pass through the vertex, which means that it's going to have the x value from the vertex coordinates down for itself. Everybody okay? So when it comes to graphing a quadratic, does anybody know what's the first thing you got to find? What's the first thing on your list? Okay, in order to find the vertex, what pieces do I need? I need B and A, right? So the first thing that I'm actually going to find is A, C, and C. Okay? So if I go to my graph, so here's my equation. The first thing that I want you to do is find A, find B, and find C. So somebody tell me, what's A up here? Okay, so A is 2. What's B? So what number makes things go away? So what's C? Is everybody okay with that? Because A is attached to the x squared term, right? If you look at our general form. What is B attached to? Just the x, right? Do I have one? No. So x is going to be any number that I pick, right? So what times any number would make something go away? 0. So that means that B has to be 0. Everybody okay with that? Yeah? And then there's a constant out here of 0, which is having no impact. So this is the, if I asked you to write this equation in standard form, this is what I would need to see. Y equals 2x squared plus 0x plus 0. This is in standard form. Everybody okay? Yes, no? All right. So moving on. Now we get to find the vertex. So the vertex, first of all, is a point. So make sure that it's written out as a point with comma and everything, right? Now, when I start this, do I find the x-coordinate or the y-coordinate first? The x-coordinate. So I need to find the x, right? So who remembers, what's the formula for finding the x-coordinate? Negative b over 2a. So and then all I do is I plug in my information. So what's my b? 0, so I get negative 0 over what's my a? 2, right? What's negative 1 times 0? 0. What's 2 times 2? What's 0 divided by 4? So I get 0. So 0 is my x-coordinate. Everybody all right so far? Okay, now how do I find the y-coordinate if I have the x? Plug it back in. So what I'm going to do is I'm going to use function notation. So f of 0, which basically means wherever you see x, what do I substitute in for? The 0. So I take my equation, and wherever I see x, I replace it with a 0, and then I evaluate. So what's 0 squared? 0 times 2. So I get 0. So my vertex is at 0, 0. Axis of symmetry. Who remembers what's the equation for axis of symmetry? So it's x equals, though, right? It's got to be the equation to a line. So it's got to be an x equals. And then it's negative b over 2a. And what did negative b over 2a get us? 0. So x equals 0. All right, and then real quick, who remembers axis of symmetry? Is that a solid line or a dashed line? Dashed. Okay. So it'll be a dashed line right through the middle of your right through the middle of your vertex. All right. So any giant questions so far, or are we doing all right? So now the only thing that's missing is I have to graph it. So I'm going to make a 5-value chart. What do you use as your standard 5-value chart? Okay, so that's for a linear equation, right? Are there any bends in a linear equation? No, you guys said it's a straight line, right? So do I really need to pay attention to where we're bending at and all that stuff? No, because there are none. So -2, -1, 0, 1, 2 always works. For a parabola, that only works if your vertex is at 0, 0. So what I'm going to do is I want you to think of these in a different way. So instead of using -2, -1, 0, 1, 2, you always put your vertex in the middle. Okay, so what is my vertex? So that is going to happen to sit in the middle of this one, okay? Because that's where the point of inflection happens. So what that means is that's the peak of the hill, right? So I need 2 numbers to the left of it, 2 numbers to the right of it, so I can actually make my picture. If you don't use that, and let's say the vertex was at 5, and you use -2, -1, 0, 1, 2, you'll make like part of a curve, but you won't have a vertex or the other side, so you don't know what the graph actually looks like. So that's why you want to make sure that your vertex is always right smack dab in the middle. Okay? So give me 2 numbers bigger than 0. 1 and 2. Give me 2 numbers smaller. Okay, so now we're going to plug these in to this equation to evaluate the y-coordinate that goes with those x-coordinates. Everybody okay with that? So plug in a 1, and we're going to use our order of operations. So I take my x and I replace it with a 1. Order of operations, what do I do first? Well, P, right? Parentheses. Do I have anything to do to make it smaller inside the parentheses? No. So what's after parentheses? Exponents. So do I have exponents? Yeah. So what's 1 squared? 1. So that's 2 times 1. Everybody okay with that? Right? Because it's 1 times 1? No, because the squared isn't on the 2. It's only on the 1. Okay, so that's why the parentheses are going to matter. No, because the order of operations says we do parentheses or exponents first. So we only do whatever is under the exponent. So you see how the 2 here is only attached to the x, right? No parentheses. So that means that I'm going to square the x, then multiply by 2. If it looked like this, now what's being squared? The 2x. So I'd go 2 times the x, then square. Okay, so there's actually a big difference between that and the other one. All right, so for us, the square is only on the x. So what's 2 times 1? 2, and that is your y-coordinate. Everybody okay with that?
Yes.
All right, so up next, put in a 2, right? We're going to square and then multiply, so what's 2 squared? 4 times 2? 8, so I get an 8. Any questions on where these numbers are coming from? All right, so try -1. What's -1 squared? 1, positive 1, right? -1 times -1 is a positive 1. What's positive 1 times 2? 2. Because they're symmetrical, they should be, but only if the distance between 0, like the vertex, and this point is the same in both directions. So here you went up 1, up 2. Here we went down 1, down 2. So we should get the same values. Plugging in -2, what's -2 squared? Positive 4 times 2, 8. Okay, so any questions on how to find your vertex, your axis of symmetry, or to make your XY chart? Yes or no? All right, so I'm at 0, 0 is my vertex. Right at 1, where was I? 2 at 2. Okay, at -1. At -2. Okay, axis of symmetry, solid or dashed? Dashed. All right, and you do need to label this as your axis of symmetry, and I want you to label your vertex. AOS or axis of symmetry or A of S, I don't care. Any of those 3, okay? But I do want you to label the axis of symmetry so I know that you know what it means. Okay, so now how do I make a parabola? Who knows? What are the characteristics of a parabola? Like what general property should it have? Okay, all the points will be connected. It'll have a curve, right? What about the bottom? Is it going to look like an absolute value function, which is a v? Yeah, it's going to actually have a rounded bottom, right? There's one other thing that students do that upset me. So when you curl up here, yeah, when you hit this point, you don't just go straight up, though. Okay, the graph is growing, and then it stops growing. Okay, that's not true. Parabolas graph, like, they go up forever. Okay, so when they go up, they also go out. So when you graph this, you'll round the bottom, go up, and then you still need to keep growing to the right. Okay, make sure you're doing that, please. I've had kids for the last 2 years make beautiful graphs, except they hit here, and then they go straight up. Parabolas don't work like that. Okay, if they're going up, they're also going out forever. Okay, they're constantly getting bigger. Everybody okay with that? Yeah? All right. So same thing over here. Make sure you have a rounded bottom. Yeah, it's close. And that's it. You're done. It's a sketch, man. Okay, so when I grade these, this is worth like 2 points, or 3. 1 for the labels, 1 for the graph, 1 for the axis of symmetry. Everybody okay? Over here, this is worth 5, 6, 7, 8, 9. So the graph doesn't really matter nearly as much as this work. Okay? So I know some of you have graphing calculators. I've had students just type it into the graphing calculator and draw the picture. Hey, cool, you got 3 points. You missed 9. You got 3 out of 12. Awesome. Okay? So this is what I really care about, making sure that you understand what is actually going on around the quadratic, not just if you can reproduce it. Everybody all right with that? Yeah? Questions, comments, concerns? No. Personal philosophies on life, topics for debate? Personal philosophies on life or topics for debate. You guys didn't have any, so I'm moving on. So, what's my A? What's my B? And what's my C? Okay, so real quick, is this going to point up or down? Down, because A is negative, right? So negative B over 2A. What's my B? Negative 2, so I get negative of negative 2 over 2 times what's my A? Negative 1. What happens when I take the minus of a negative 2? It becomes a positive 2. What's 2 times negative 1? Negative 2. So what's 2 divided by negative 2? Negative 1. So there's your x-coordinate. Done. Now to find y, I take my x-coordinate and plug it back into the equation, right? So wherever I see x, replace it with negative 1. So what's negative 1 squared? 1, so I get minus 1. What's negative 2 times negative 1? Positive 2, and then I have another minus 1. So what's negative 1 plus 2 minus 1? 0. Everybody okay with that? Yes, no, maybe? So now I put my vertex right in the middle of my XY chart. Again, I need 2 numbers bigger, so give me 2 numbers bigger. 0 and 1. And then give me 2 numbers, well, 2 and 3 would work. Give me 2 numbers smaller than negative 1. Everybody all right? So plug in 0. What's 0 squared? Negative 2 times 0. 0 plus 0 minus 1? Negative 1. 1 squared is 1, so you get negative 1 minus 2 times 1 is negative 2. So negative 1 minus 2 minus 1 is negative 4. All right, plug in negative 2. Negative 4 plus 4 minus 1 is negative 1. Negative 3 squared is 9. Negative 2 times negative 3 is 6. Negative 9 plus 6 is negative 3. Take away 1 is negative 4. All right, I know we're running out of time. That's why I'm going kind of quick. Only if the distance between the x-coordinates on the vertex and the points above and below are the same. So, like, what's the distance between negative 1 and 0? What's the distance between negative 1 and negative 2? So they should be the same. What's the distance between negative 1 and 1? Negative 1 and negative 3. Their answer should be the same. Okay? So you just have to be careful with that. All right, so when you graph this, you're going to get negative 1, 0, 0, negative 1. 1 was negative 4, 2, 3. -4. Remember, your axis of symmetry has to be a dashed line, so you're going to go through the x-coordinate of the vertex. Make sure to label it as the axis of symmetry. Make sure to label your vertex. And now that you have all your information, you'll just graph. So make sure you're curved at the bottom and pass through your points. Other than that, here's your homework. I want you to come in with questions ready to go.